Section 2, looking at example 2, identifying extrema. Extrema, I'll show you an example of them, but they basically are your relative maxes and your relative mins, where there's hills and where there's valleys in our graph. So this is an x cubed, so the degree is 3. So I know this should look something, and the a is 1, right? The number in front is a 1, so it's a positive, so it's going to go down to the left and up to the right. Okay, so we don't quite know what's happening here. So we can make a table, so we can plot these, or you can put it in the graphing calculator and see what it is, right? But then we're going to estimate what the x coordinates are of our relative maxima and relative minima. Those are just extrema, what they call extrema. And so those are just your relative max and relative mins, just kind of different words used for it. So if I plug in -4 into this equation, I get 30. If I plug in -3, I get 5. If I plug in -2, I get 4. If I plug in -1, I get 3. Plug in 0, I get -2. Plug in 1, I get -5. Plug in 2, I get 0. And then finally plug in 3, I get 19. So plug in all those values into the equation, that's what I get, or I can graph it, look at a table, see what it looks like, and then I can go ahead and graph this function. So when I graph it, again, I can label my x-axis, my y-axis, x-axis, plot these points, right? -4, so 1, 2, 3, 4. I'm at -30, so I'm way down here, right? So I'm way off the board, right? And we can tell that by our end behavior. Then I'm at -5, at -3, -5, then at 4, then at -1, I'm at 3, and then at 0, I'm at -2, so drop back down here. At 1, I'm at -5, at 2, I'm back to 0, right? So I can see I exactly crossed my x-intercept right there. And then at 3, I'm back up to 19, way up here, right? Okay, so if I was to graph this, it looks something like this, right? You're coming through here. It's probably not going to be the best graph. At somewhere, I turn around right here and come back down, right? I'm heading up, and then I turn back around. Well, at that point right there, at that value, is a relative max. Maximum. Well, they call that a relative maxima. So same thing, relative means the same thing, maxima. Okay, and that's called an extrema point. Okay, so where we have this hill right there, it's relative, and then it comes back, and then we go and we turn again. So right there where we turned right there, that would also be an extrema point, right? So we reach to an extreme and then we turn, right? So that's a relative max or a relative maxima at the hill part, and then at the valley part is a relative minimum or relative minima. Okay, so those terms mean the same thing. Those are called extrema points. Okay, and so we want to estimate where is this x. So this one's between, right, this x and this x. So if -2 and -1. And we can see that where we turn around at -2, we go 4. We're heading positive, and then we turn back around and go downwards, right? So we're heading up, and then we turn down. And then we can see we're starting to head down, 3, negative, and then we turn back around. So somewhere we turn back around right here as well, right? And so in calculus, when you take calculus, they actually calculate what this value is exactly, and they calculate what this value is exactly. So that's what they do in calculus, is they actually look at it and see. But for now, we're just going to estimate. So we're going to say this is somewhere between x equals -2 and -1, right? Somewhere in between there. And then this one, it's somewhere in between 1 and 2. So somewhere in between 1 and 2 as well are those relative maximas. So this is a relative maxima, and this is a relative, I guess I'm using the same letters, right? So relative max, and this one would be the relative min. So wherever you have hills is a relative max, and wherever you have valleys is a relative minimum. Or you can use maxima, or you can use minima. Those are called extreme values. Okay, so that's it for identifying those.